In this video we will develop a simple project to introduce you to the LITIC Explicator. As you can see from the drawing, there are four major building blocks. First, there is the ETL component to extract data from files, to translate tabular data into cubes and dimensions, and to load all data cubes into the project. Secondly, the Explicator has a visual editor to enter cube formulas and procedures using drag and drop. Thirdly, the Explicator offers a facility to build models to guide optimal decision-making. Last but not least, the Explicator has built-in features to view data in the form of tables and charts to support decision-making. At this point, we are ready to address a simple version of the warehouse location problem. We will build a model to decide which warehouses will be selected to meet customer demand. In this example, 3 out of 5 available warehouse locations are selected. Let us start with a new project, and name it UK Warehouse Selection Problem. Note the option to start importing data. Click on the Data button, select Import Data, and upload a spreadsheet file. Note that each sheet is presented as a block of columns. By default, columns are considered to be data cubes. It is your task to decide which columns are key columns and to make each one of them a dimension. All remaining columns are then data cubes defined over these dimensions. You can add extra useful information such as the units associated with data cubes. Assuming that the data is correct, we are ready to load the multidimensional cubes into the project. As you can see, all loaded data cubes and their dimensions are now available in the organizer. You have the option to save the ETL construct as well. To start with, we need to declare several decision-related data cubes. One main decision is the yes-no selection of each warehouse. Another decision is the amount of transport between a warehouse and a customer. Other new cubes reflect cost considerations. Finally, there is also a transport filter cube with a scalar cutoff cube to discard far-away customers. The content of the filter cube can be specified as a formula. Such a formula is always kept up to date following any changes in input data. If management indicates a cutoff distance of 100 km, then several warehouse customer combinations are no longer considered. The transport filter must be attached to the transport cube. The filter will then limit the domain of the transport cube throughout the entire project. Following these preparatory declarations, we are ready to build a new optimization model. As you can see, there are 3 major sections to be completed. The solver output section must contain all decisions to be made by the solver. The relevant decision cubes can be dragged from the organizer. The objective section must contain a scalar cube reference to be minimized or maximized. The Output Requirements section contains conditions that must be met for any solver output to be meaningful. A typical start is to describe the relationship between all relevant cost components. Just observe the process of how to build the resulting requirements. The second requirement makes sure that there is a fixed charge based on warehouse size for each selected warehouse. In the third requirement, total transport cost is derived from the multiplication of the transport rate times the distance. The next requirement makes sure that customer demand will be met. The last requirement guarantees that shipments from a warehouse will not exceed warehouse capacity. A simple touch of a button will activate the solver to solve the model. Solver output data can be inspected in various ways. One quick way is to select several output cubes and drag them into an empty sheet. Show them as regular tables, and the system will automatically organize them. It gives you an overview of transport values, selected warehouses, and total cost values. You can get more insight by viewing some of the data using charts. Select a new empty sheet, and show the aggregated transport per selected warehouse in a bar chart. Sort the bars from large to small. In addition, the relative size of cost values can easily be shown using a pie chart. Auto placement will quickly adjust the position of both charts. Next, select a new sheet to show transport data inside a geomap. Note the extensive dialog to specify various inputs related to groups of nodes and arcs. Both latitude and longitude values are required for both the customer and warehouse nodes. The transport values are the main input to show the arcs connecting warehouses to customers. Extra inputs such as distinct shapes and colors for different groups of nodes can easily be entered. You can adjust the view to hide any unused nodes with a single click. By clicking the Home button, the view is maximized. At this point, we will conclude with an invitation to look at other more detailed videos that will show you many features of the LITIC Explicator.